All right, everybody, welcome to the video here for lesson number, I don't even know, 4 on incredibly useful ratios. So in this lesson, we learned about the ratio between sine, cosine, and tangent in the two different angles of each triangle. So one of the things that we learned about was there was a quick little way of remembering the three ratios, which is SO, CA, TOA. That just helps us remember the ratio. So for the sine of D, if angle D is the angle we're using, the opposite side of D would be 15, or side EF. So I would say this ratio is 15 divided by the hypotenuse side, which is the side opposite the 90-degree angle, so that would be 17. For the cosine of D, that would be the side next to angle D that's not the hypotenuse, so that would be 8 over the hypotenuse. The sine and cosine should always have the same denominator. For tangent of D, it's the opposite side, O, over the adjacent side, so that would become 15 divided by 8. Now, for the next three, we're not using angle D anymore, so I want to either erase that or make it a different color. I want to use angle E as my marked angle. So if angle E is my marked angle, the opposite side now is the side labeled 8. The hypotenuse is still 17. The adjacent side is marked 15 now, and the opposite over the adjacent side now just becomes 8 over 15. Now in the next lesson, we'll start to look at some of the things and patterns that we notice. So what I want you to notice is that A, the sine of D, is the same thing as the cosine of E. I also want you to notice that the cosine of D is the same thing as the sine of E. So we have some same fractions going on here. So that might help us look for something that we can use. And that's what I'm asking you here on the bottom of the page. So it says, looking at your answers from question 1, what do you notice about the sine of D and the cosine of E, the cosine of D and the sine of E? Do you think this happens in all triangles? So we could say the sine of D is equal to the cosine of E. And we can say the cosine of D is equal to the sine of E. So why do you think this happens? Well, since we're changing the angle that we're referencing to, all that's going to change is the opposite over the adjacent. The other thing that's interesting is since this is a right triangle, one of the angles is 90, so angle D plus angle E must equal 90 degrees. So these angles are what are called complements to each other. Since this is going to happen in all right triangles where we're going to have this complement with the two remaining angles, I think this is going to happen for all right triangles. There's your answer, right? Obviously, I want you to explain what I just said in words. I'm not going to write it down here on this on the video, right? You could kind of take what I used and put it in your own words. That would be awesome, right? If you don't fully understand number 2, don't worry about it, because that's what we're going to be talking about the whole lesson here in lesson number 5 tomorrow. All right. Good luck with your homework, and I will see you all tomorrow.